Human evolution. For a species to evolve, it needs to go through some physical, cognitive, and social changes. Humans are from the hominid family, the great apes. Let's explain from the beginning where do we come from. Diprotodontids. They live in the Miocene period in Africa. This species split in different families. In the Middle Miocene, we found two new species, Kenipithecus and Gryphothecus, which traveled to Europe and Asia. Then we have another branch in the late Miocene, the Jamorthithecus, in Asia. And then in the Pleistocene, we found the gibbons in some islands of Asia. We can also find evidence of other species in the Miocene, the Pyrlopithecus, the Oreopithecus, and the Dryopithecus. In the late Miocene, the climate got dry and the forests reduced their number. Some apes who lived in the forest died out. They were replaced by African and Asian apes. We can find the Stibapithecus, Charopithecus, Pongos later in time, and Carapithecus and Lephinthecus. On the other side, we find other branches, the gorillas, the pans, and the Australopithecus, our more directly ancestor, with a brain size of a chimpanzee. It splits around 2 million years ago in Paranthropus and in the Homos, humans. These species are from the great apes, the hominids, but the branch Homo is called hominin. We classify the Homo in subspecies. First, we have the Homo habilis, which use tools primarily for cutting meat, rather than defense or hunting. Around 1.8 million years ago, we found the Homo erectus, the longest lived of species. Through all of this time, they traveled from Africa to Eurasia. This phase is known for its stability, as we can see in the size of the brain that barely changed. 500,000 years ago, we can locate Homo heidelbergensis, known for its explosion on brain size and culture. Around 240,000 years, we found the Homo neanderthalensis, with a body more prepared for high-altitude habitats because of the Ice Age. They traveled from Africa to Asia, Australia, and Europe. 200,000 years ago, the Homo sapiens appeared, our ancestors. Their brain was smaller than ours, and their body more robust. We know that we come from the Homo sapiens thanks to the molecular clock, which deduced through DNA when two or more life forms diverged.
While we are not just great apes, we have some radical difference like anatomical difference, in particular our bipedal stance to avoid extinction. Much of the rest of the debate has been around instrumental behaviors like tool making and tool use. But the real difference lies in our cognition and what we can do inside our minds. This has given us culture that produces literature and art. Behaviors and cognitive abilities that characterize modern humans are also found in some form in our nearest relatives, but what apes do with their cultural abilities simply pales into insignificance by comparison with what humans do. There's two key aspects of culture that stands out as being uniquely human, like religion and storytelling. Both require language for their performance and transmission. Both have played a fundamental role in human evolution. Other important aspect of human culture is the social performance of music. What underpins all these cultural activities is our big brains, and this distinguishes us from other great apes. 5 major transitions in the course of human evolution. Each one is based on a major change in brain size or ecological circumstance. First, we have transition from apes into the Australopithecines and involves mainly an ecological and anatomical transition with no evidence for any significant change in brain volume or cognition. After this, there are 3 phases of brain evolution, starting 2 million years ago, significant jump in brain size with the appearance of the genus Homo 1.8 million years ago. Around 500,000 years ago, associated with the appearance of archaic humans, the Heidelbergs, and 200,000 years ago, further rapid increase in brain size that comes with our arm spaces, anatomically modern humans, Homo sapiens. To this, we will add another one that doesn't involve any change in brain volume, that is Neolithic revolution. It took place around 12,000, 8,000 years ago in Everest. It's characterized by two major innovations: switch from nomadism to settled villages and the invention of agriculture.
Time budget model. It's a model that predicts how much time an animal spends in an activity like eating or traveling. For the brain to grow its size, it needs to be fed. Therefore, they need more time to eat. And if this activity needs extra time, traveling or socializing should be reduced.
The basis of primate society. Primates are intensely social, and their bond relationships allows them to form groups that remain stable and coherent over time. The main reason why they live in groups is as a defense against predators, because the risk of being caught by predators increases as they become more terrestrial and occupy more open habitats with fewer trees. This has its benefits, but also its costs, like indirect cost. More travel time has to be allocated within the working day. They have to satisfy everyone's nutritional requirements, leaving less time for other activities. Travel also consumes energy and exposes the groups to additional risks of encountering predators. A primate group is an implicit social contract, and social contracts are susceptible to being broke by free riders, benefiting doubly at everyone else's expense. We also have direct costs, arise from conflict within the group. All of these increase in frequency as groups get larger. These are borne mainly by females because the stress of living in a group impacts on female menstrual cycle endocrinology and leads to infertility. Thus, female reproductive strategies become a crucial factor that puts a natural brake on runaway increases in group size. Diffusing the stresses of group living. Monkeys and apes neutralize the stresses created by living in groups by forming coalitions that buffer their members against harassment. These involve two separate processes that interact to create these bonds. Emotionally intense mechanisms triggered by social grooming. It triggers the release of endorphins in the brain, and this allows animals who groom together to stay together long enough to build up a relationship of trust and obligation. Oxytocin, or love hormone, is also released during close social interactions. Grooming and other forms of light social touch trigger activation in a special set of neurons that respond specifically to light touch on the skin and convey these sensations directly to the brain. Like stroking between romantic couples triggers an endorphin response in humans. Grooming and other forms of light social touch trigger activation in a special set of neurons that respond specifically to light touch on the skin and convey these sensations directly to the brain. Light stroking between romantic couples triggers an endorphin response in humans. The endorphin release is experienced as pleasure and calmness, so it seems involved in the process for forming the kind of deep attachment that we find in anthropoid primates. We found a theory of love by Stenberg. He finds love in terms of three independent dimensions, like passion, intimacy, and commitment. Intimacy and commitment suggest that relationships have two key components, like being close, that seems to reflect the grooming element in primate relationships, and feeling close, that seems to reflect the cognitive component.
How cognition underpins sociality. Even if we don't know for clear how our social cognition works, the most extended theory that we know about is known as theory of mind. This theory gets this name in fact that defines that individuals had their conclusions about how having mind is like. Humans are born with this theory, but they develop it until the age of 5 years, and then gradually process until they reach the normal adult competence, when they can think about other one's mind. Brain imagining has revealed that mentalism is processed the same way, the same brain areas as the theory of mind. It involves part of the prefrontal cortex and two main areas in the temporal lobe. The higher level of intentionality, the higher neurons have to be required to get answered right. It produces that species that need to be able to work at higher orders of intentionality will need higher brain size. For these reasons, the frontal parts of the brain that have evolved more in anthropoid primates and are largest in those species that are socially more complex. There is some experimental evidence that great apes can just both cope with second-order intentionality. They are certainly not as good as a 5-year-old children. They are just beginning to get hang with the idea of their own mind. Primate social evolution. Everyone agrees that the ancestral primates were small and nocturnal, and lived in dispersed semi-solitary societies, in which females foraged in small individual home reigns with minimal overlap, while males lived in large territories defending against other males. And there is thought that subsequently social evolution involved the gradual coalescence of the individuals in permanent groups, but some recent studies explain that the species start living in isolated societies, and maybe because to avoid the danger of predators or whatever, they grow together. The first societies had produced two different options. The first one was the society that there's created a society, and the second one is the monogamy. Now I'm gonna explain some points of monogamy. The scientists try to explain why monogamy has no comeback, because in many species when they the monogamy road, they can go back and form another kind of society. This may be because of the biparental care need, maybe because of the mate guarding, or because of the infanticide risk. Another study explained that maybe the mate guarding is the key to explain why in many males they are monogamy, but in primate cases this isn't common. It may be because in primates the males can defend the females from several other males instead of only one. We must have these concepts in our head if we want to explain the hominin society evolution, because we practically act like the primates. And as a conclusion, it brings us two fundamental principles: the brain size and the time budget. It says that the brain size in some way defines the future social group size, and at the same time this will define the time budgets that we'll search in future times.